scrolling through your music app, like, how does it know what I want to listen to next?
Yeah.
Or maybe it's more like when your inbox is completely free of spam and you're like, okay, this is magic. But actually, you know what? It's not magic.
Yeah.
It's machine learning frameworks
Yeah.
working behind the scenes.
Behind the scenes, exactly. Like these little masterminds driving the AI revolution that everyone's talking about.
Yeah.
But they're not people, right? They're lines of code.
There are these toolboxes. Like imagine, if you will,
Yeah.
a toolbox, but instead of hammers and wrenches,
Right.
it's algorithms and data sets
Yeah.
that developers use to build AI.
It's like having all of the ingredients laid out in front of you. You've got your recipe book, and yeah, you're ready to cook up some AI.
I love that. I love thinking about it as like a recipe book. And each of these frameworks has its own personality, its own style.
Absolutely.
And I'm thinking about like we've got like the reliable, like the scikit-learn that has been around for a
Yeah,
while.
the old stalwart.
It gets the job done.
Yeah.
Then you've got these like kind of like the new kids on the block, TensorFlow, PyTorch.
Which are huge.
Huge. And this is what I think is so fascinating about all this. It's like it's changing so quickly. ChatGPT, who we talked to for this deep dive, actually walked us through the history, and it is mind-blowing how far things have come.
It not that long ago, like relatively in the grand scheme of things, where developers were like literally, like you said, like hand coding every single algorithm.
Yeah.
And then around the early 2000s, you had libraries like scikit-learn coming out, making things a little easier, more accessible. But the real like game changer was really deep learning that came out around 2010.
Deep learning, yeah. It's like going from riding a bicycle to all of a sudden you're being launched into space.
Exactly.
Right. The capabilities just exploded.
Huge leap.
And that's where you get frameworks like TensorFlow, which was created by Google, PyTorch, which was created by Facebook.
Right.
They're built for this deep learning.
Yeah.
And it's complicated stuff.
Oh, absolutely. It's like, if you're building a birdhouse, you can kind of use any old materials. But if you're going to build a skyscraper, you need very, very specific tools. And that's what these frameworks provide.
Totally. And speaking of these big players, ChatGPT did give us some insight into the market share. TensorFlow.
Yeah.
Still holding strong.
Okay.
About 35 to 40%.
That's a lot.
It's a lot, which isn't surprising, right? Google's behind it. But here's where it gets interesting, I think.
Okay.
PyTorch is coming in hot.
Really?
About 30 to 35%, so not that far behind.
Wow. I wonder what's driving that.
And it's rapidly gaining popularity in the research world.
Well, that makes sense. I mean, because from what I understand, it's pretty user-friendly, right?
Yeah, and it's really flexible.
Okay.
So researchers can use it to kind of like experiment quickly. And in that world, speed is everything.
Absolutely. You got to iterate quickly, and it sounds like that's what PyTorch allows you to do.
It's like the new kid that all the cool kids want to like work with in the lab. Yeah. But one thing I do want to clarify here, because we hear these words thrown around a lot, deep learning, transformers, those aren't frameworks. Those are techniques and architectures used within these frameworks.
Exactly. Think about it. Like if we're going back to that house analogy, the framework is really like your foundation, your framing. It's what provides the structure. Deep learning is more like the architectural style that you choose. So are you going to go for like a modern style or Victorian, something like that? And then transformers are like prefabricated walls or roofing systems that you're going to use within that style.
I love that.
Yeah.
That is a really like clear way to think about it. So we've got these amazing tools, these frameworks, building the AI future. But there's a whole other side to this.
Yeah.
The business of AI. And that's where All right, ready to dive into some seriously wild tech. We're talking deepfakes.
And not just like those silly face swap apps. This is next level.
Oh, absolutely. We're talking about the future of fakery, people. This research paper, the 1M Deepfakes Detection Challenge.
Catchy title.
Right. Well, they're basically trying to crack the code on spotting these crazy, realistic deepfakes.
Which is getting harder by the minute. The tech is evolving so quickly.
It's true. Imagine a world where you can't even trust what you see in a video. That's what we're talking about here.
And that's exactly why this research is so important. This paper comes from a whole team of researchers around the world who are building this massive data set of deep fakes, over 1 million of them, to help train AI to be like super detectives.
1 million. That's insane. What's it called? The data set?
AV Deepfake 1M. And it's not just, your run-of-the-mill face swaps anymore.
Oh, so way beyond just pasting one face in another person's body.
Way beyond. We're talking about these tiny little fake segments spliced into real footage, like blink and you'll miss it.
Oh, wow. So you could have a video that looks totally real, but there's like a few frames that have been manipulated to change the entire meaning.
Exactly. And that's why this research is so crucial. Those old, smaller data sets they used before, those are like kids' toys compared to what we're dealing with now.
So how does this challenge actually work? Do they, show these videos to a bunch of AIs and see if they can spot the fakes?
It's a little more complex than that. There's actually 2 tracks to the challenge. The first one is detection, which is pretty much what you described. The AI has to decide real or fake.
Sounds simple enough.
Well, it's not that easy. Not anymore. Tracks to the challenge. The first one
Difficult.
to do more than just say if a video is fake. And the haystack is a 2-hour movie.
Okay, yeah, that sounds incredibly
Yeah.
difficult. But why is that so important?
Think about it. Imagine you're watching a video of a politician giving a speech, right? Detection might tell you something's off, but localization could tell you exactly what words were fabricated.
That's huge. I mean, it could expose a whole campaign of disinformation.
Exactly. And that's the real-world impact of this research.
So we're talking about finding these tiny manipulations, but honestly, the thing that really got me was how fast this tech is changing. The examples in the paper, it's kind of wild.
It's like you blink and the deepfakes have leveled up again, you know? The researchers actually included this family tree of deepfake data sets. So you can see how things have progressed.
And they made a point of saying this isn't just about faces anymore, right? What do they call it? Beyond facial manipulation.
Yeah, exactly. And that's what makes it so tricky. Imagine a video, right, of some CEO giving a speech. Detection might say it's legit, but then localization could be like, hold on, that background's totally fake.
So you might think they're at their company headquarters, but really.
And they're on a yacht somewhere. Or think about a conversation. Someone's gestures could be subtly messed with, like a clenched fist here, a forced smile there.
And suddenly you're seeing their emotions totally differently.
Exactly. They're creating a narrative, and that's what's so different now. It's not just swapping faces for a laugh. It's about, manipulating the whole story.
Which is kind of terrifying, honestly. But there was something in the paper that gave me a little hope. It said that this whole 1 million deepfakes challenge.
It's ongoing.
Yeah, even though the 2024 challenge is over, people can still submit their question everything.
Exactly. Trust, but verify. Always a good motto.
100%. Well, on that note, I think we've successfully navigated another deep dive.
It's been a pleasure, as always. Until next time.